last but not the least, we want to look at anomaly detection tasks. And when you talk about anomaly detection tasks, what other data set fits it, if not data set like fraud detection? And then, the reason is because this data set, these sort of things are rare occurrences, although not in some countries like maybe Nigeria, but in the same country, these things are rare occurrences. You don't really see them happening sporadically like that. So most of the time, you are interested in predicting those things because fraudulent transactions are a growing challenge for fintech companies. So this data set has about 51,000 plus transactions, and each labeled as fraudulent or legitimate activities based on the real world patterns. So it includes transaction details, users' behavior, payment method, device usage, making it ideal for fraud detection modeling and also for anomalous detection. So it's a good data set that actually reflects, especially for the people in the financial areas that applies machine learning. This is a very good data set for them. So in order for you to go ahead and start modeling this data set, it will make sense if you could actually see some of those hidden patterns that are in the data set. And anomaly detection provides you the right tools to be able to see these patterns. So that's why we're doing this anomaly detection approach. So the first thing is we call the data set, again, with this data set, we are calling it from Kaggle. That's where we're calling the data set from. And you could actually see it is a very current data set of Kaggle here. Yeah. Let's see fraud detection data set. So like I said, always check this Kaggle. It's a good place. So this is where the data set came from. And I think it was a very recent data set. If I'm not mistaken, the data set was let's see. Yes. So you can see it was uploaded 6 days ago by this Ranjit Mandel or Mandal also. So it's a very recent data set, that came in. And then you could see another data set that came in 23 days ago on social media post data set. There is also data set on global energy consumption, global water consumption, cloud satellite, Maxi data set, Fitbit fitness tracker data set, step tracker data set. So many, you see lots of data set. Anyway, and even the mental health data set I talked about, it was from here we got it from. So you run this to call the data set, remember? So it's a nice one. You could see the transaction type, ATM withdrawals, bill payments, the transaction amounts, the user ID, the location where the ATM was used, previous fraudulent transaction, the amount each, the number of transactions last 24 hours. So, this data set is a very good data set. And these are some of the things that you could help banks to be able to uncover, because places like Nigeria, for example, where you see this heightened issue of fraud and cybersecurity threats, these are some of the things when you could get them told, okay, we need to see your data set, we need to do some of these things. So this is a very interesting project that I did advise you, to go about doing, because it's really helped you to uncover things that are quite helpful to the society. So the next thing we need to do is, first of all, if you notice, when we call this data set, we set the transaction ID to the index column, because we will not use it. So, but again, it's quite relevant to us. So we still reset it to maintain the index column. So like I say, perform some EDA, try to know what the data is saying so you could have a proper understanding of the data set. which is what we did. And also the summary statistics, try to have an insight of what the summary statistics is saying. And then the next thing you do is to also perform some missing values evaluations to know how is the data. So you could see there is a missing value in the transaction amount. There is also missing value in the time of transaction, the device used, the location as well. And also there is a missing value in area of payment method. Then the next thing we needed to do is to visualize the variables. But in this case, we are going to visualize the numeric variable, because if you could see here, we did have some objects and then we had some integers and floats. So we are interested in visualizing the numerical variables, which is what we are doing here. So again, we're trying to look at these variables, which gives us a nice distribution. The user ID, we are not really interested. You won't see any pattern, of course, because this could be a very unique number. But the transaction amounts, we do see that it was highly concentrated around this point, which means it was not really a big amount, although, but it's quite significant. But we could see some spike here, around 500, no, 50,000, which, it's quite interesting. Then time of transaction, we also see it's kind of unique. We also could see the fraudulent transaction, and then account age, and then we could see number of transaction within the last 24 hours. So another thing again is to visualize the distribution of the categorical variables, because we're also interested to see how these trends appears in the categorical variables. So taking a look at the categorical variable, like the transaction type, you could see the ATM withdrawals, the bill, the POS, transaction, bank transfer, online purchase, etc. Actually, we could see bill payment seems to be relatively high, and bank transfer, I think the both of them seems to be a bit a peak. And then ATM POS payment seems to be quite a bit lesser from the other ones. And then we can see on the devices used, unknown device has the lowest. Most of the devices that these scammers or fraudsters use are mostly desktop, mobile, and also tablets. And then on the location that these fraudsters operate from, we could actually see a bit of, I think the highest was Seattle, and then followed by Boston, and then New York. And I think the lowest also probably within San Francisco and Miami and Los Angeles. So I think this seems to be lowest. Then the payment type, debit cards seems to be the most. No, UPI seems to be the most, and then followed by debit card, and then credit card, and then the lowest was invalid method. And all that. So the lowest was, yeah, that's the lowest. Then the next thing we need to do is to see if we are going to find some correlation, potential correlation, which is very important. And remember, the correlation can only be done on the numeric variables. So we are interested in looking at the amounts and also the time of transaction. Like I always say, these are rare occurrences. So there is that high chances you will not really see any form of spiral correlations happening. But this is a way of making you to what you are really looking at here is going to be a positive, or this is sort of a negative sort of relationship, stuff like that. Those are kind of things you'll be looking out for. But um, we didn't really see any form of correlation as such. But again, we would get to see what happens. So we are not interested in removing those missing values. Instead we take care of them by using the median for continuous variable and also the mode for categorical variables. So the next thing we want to do is to perform some sort of future engineering, we do not want the user ID because it's from the visualization here, you could actually see that we are not really getting anything from the user ID. And these scammers, of course, will not want to use one particular user ID. Sometimes they will change their identity in order to evade detection. So we perform some sort of one-hot encoder because we are interested in the categorical variables here. We don't just want a location, but we want to know which location exactly. Where is this thing really happening? For example, when we are looking at transaction type, we are not just interested in the transaction type, but what sort of transaction type? Is it a POS payment? Is it a bank transfer, etc., that is being used? So that's what you see we're trying to do here by performing the one-hot encoder. So like I told you in our previous classes that the one-hot encoder open up the dataset and then we could be able to see it. So it's like a closed book that has so many pages. When you open it up, each of those pages becomes a column on itself. So that's what we're trying to do. So again, we drop the user ID. Like I said, we don't need it. Then secondly, we standardize the dataset, which like we have done in the previous class. Then now we can now begin to perform the anomalous detection. The anomalous detection, we use an assemble method called isolation forest. Isolation forest behave like a random forest. So again, it's sort of looking like a supervised sort of approach, but yet, yeah, then one of the reasons because we are going to try to detect what is going to be anomalies from them, which ones looks odd, and then like we pointed out in the theory part of the course, that normally you are looking at the odd person here. So when you have all this group of fish, which ones are facing or the black sheep or sort of. So the isolation forest actually provides us a good way to know or to detect this thing. So if you want to know more about it, you could actually go to skip-learn assemble method and you could read a bit on isolation forest algorithms. However, what you do is to define the isolation by looking at the contamination level and also the random state. The random state, like I always say, is to how you shuffle these things. And then the contamination should usually have to be very small. That's why you see we started from 0.05. It shouldn't be this large. So you could be able to really pick up signals. So the next thing is you have to fit on the scaled data. So remember, we perform the hot and code and encoder, and then the next thing is we scaled the data set. So that's what you see that we did here. So the hot code and encoded is done here, and then yeah. So the next thing is we standardize again, which is what we have done previously. Then we scaled the data set, so which is what we're now doing next. So we scaled it, and then the next thing is to now attach the label, because when we perform the isolation forest, we make prediction. So the prediction will produce a label like we did in the k-mean clustering, and then we attach this to the original data frame. So next thing we need to do is to perform sort of supervised learning. So which is what we did here. And then after the supervised learning, sorry, I said supervised, principal component analysis. So the next thing is to visualize the PCA and color them based on the anomalies that we have detected. So which is what we have done here. Now you can actually clearly see a pattern here. You can see there is quite a very interesting separation here. So the minus ones are the distortions or the anomalies in the data set. So you could see there is a very good number of anomalies in each of them, but most especially this one here. We did see quite a very good anomalies. So the next thing is to count how many of them we have. you could actually see the number of anomalies here. This was around 2,550, while the normal ones were around 48,000. So this should be the normal transactions, and these are the fraud that were detected from the anomalies. So another thing is to map them. So you could start from 1 and 0 instead of just 1. Then, so these were just more of future engineering approaches that we did. But again, we are interested in quantifying this whole stuff. So that's what you see we are doing. So we want to know how precise the detection was. So the accuracy, for example, the precision was 97, the recall was also 97, and then the F1 score was 97, and then the ROC was around 78. So which means our model looks quite promising. Then the next thing we are going to do is to open up the classification reports to see more about what is happening. And I could tell you that the anomalies were not that great because of the imbalance in the data set. And that's quite another class for another day. We have to find a way to scale it up so that our model will peak, because most of what our model is predicting to be correct is coming from the negative class instance. So we have to find a way to upscale it so this one could also perform better. But notwithstanding, this is quite a good score. The F1 score is not bad, the precision is not bad, and the recall too seems to be okay. So another thing is the confusion matrix will help us to see how well, which ones are really missing. So we can get, at least we are getting 1,474, right? While we also at the same time, we missed out around 1,036. So we can do better by finding a way to make our model to discriminate in order for us to pick more fraud than not to pick. But when you looked at the normal cases, we pick a lot of them, and it was very few that were classified as fraud. So the exercise is going to be discuss the implication of the finding and how do you find a way to improve it. So like I said, one way to improve it is for you to balance the algorithm, find a way to balance the weight so you can be able to identify most of this.